mixers. So when we mix pepper with sugar, that is an example for heterogeneous mixer because we can see pepper and sugar separately. That is very easy to visible that type of components. Then another difference is we make a sugar solution by adding some sugar to water. After stirring, if you take a drop from here or if you taste a drop from here, all these parts have same concentration of sugar after stirring. That means throughout the mixer there is uniform concentration of the salt and sugar and water. So in all homogeneous mixer, their concentration throughout the mixer is uniform. That means concentration throughout the mixer is same. Otherwise, if you take water and add some sand, or we are adding chalk powder, anything we can add. If there is sand, we know that sand is more denser than water, so that will sink to the bottom. So when we take some amount of water from the top side, we'll get only water. There is sometimes there is some amount of sand particle, but it will be less. But when we take a pinch from here at the bottom side, we can see there is more sand particles than at the top. That means there is no uniform concentration throughout the mixer. Concentration will be different at a different space, different region. There is a main difference between homogeneous and heterogeneous mixers. That is, in homogeneous mixture we cannot see the individual components used for making that solution. That is, there is no visible boundaries between the components. But in heterogeneous there is visible boundaries between the components. Then uniform in homogeneous or throughout the mixer the concentration will remain the same. That is uniform concentration throughout the mixer. But in heterogeneous that is not. That is concentration will be vary in different region. There will be no uniform concentration throughout the mixer. So these are the different classification of matter. What are they? Elements, compounds and mixer. Then we study that in compounds, elements are combined in a fixed ratio of their mass. Then when elements combines, they have to follow some rules. During chemical combination of elements, there are some rules are following. So we will discuss next the rules which governs the formation of compounds. That is called laws of chemical combination. Laws of chemical combination, and first law is a very simplest law, that is called the law of conservation of mass. It's a very simple law introduced by Lavoisier. According to him, during a chemical reaction, there is no change occurred to the total mass of matter. For example, when carbon combines with oxygen to form carbon dioxide, these are called reactants and this is called a product. This is called a chemical reaction, that is a conversion of reactants to product is called a chemical reaction or a chemical change or a chemical combination. Here carbon and oxygen chemically combine to form carbon dioxide. According to the law of conservation of mass, during this chemical change, total mass will be same. That means mass cannot be created or cannot be destroyed. It is always, mass of the universe remains always constant. Or simply we can say mass of reactants must be equal to mass of products. That is the law of conservation of mass. Mass of reactants must be equal to mass of product. Or we can say during a chemical reaction there is no change in mass. We can prove it. For example, mass of carbon is 12 when it is combines with the 32 gram of oxygen. Total mass is 44 gram. Then here carbon, what is the mass of carbon dioxide? The same, 12 plus 32 total is equal to same. That means mass of the reactant must be equal to mass of the product. This is the first law of chemical combination, that is called the law of conservation of mass. Then second law, that is called law of definite proportion. Law of definite proportion. Or one more name that is used, law of constant composition. Law of constant composition or law of definite proportion. Then according to this law, same compound always contains same elements combined in a same ratio or fixed ratio. That means carbon dioxide. We can obtain carbon or we can produce carbon dioxide from various methods. For example, we can burn carbon with oxygen, we will get carbon dioxide. Or by respiration. During our respiration, we are giving out carbon dioxide. By burning fuels, by burning CH4, we will get one of the product as carbon dioxide, and the products are also formed. So we can prepare carbon dioxide by using, or we can obtain carbon dioxide by so many methods. In all these methods, the obtained carbon dioxide contains same elements. What are they? Carbon and oxygen, and they are in the same ratio. And what is the ratio? 1:2. Same compound always contains same elements and they are combined in a fixed ratio of their mass. That is called law of definite or law of constant composition. Another example, water. Water can be obtained by burning hydrogen and oxygen, or by using rain, or we are taking from river or pond, so many methods are for obtaining water. All this water contain hydrogen and oxygen and they are in a ratio 2:1. That is called a law of definite proportion or law of constant composition. That is a second law. Then we will go to the third law. That is called a law of multiple proportion. All the names give their definition actually. Multiple proportion. According to this law, when two elements combines to form more than one compound, then one of the elements' mass is fixed, then other elements are combined in a simple ratio of their mass. Example, hydrogen and oxygen. Can you say compound formed from hydrogen and oxygen, that is called water. And here they are in a ratio 2:1. 2 hydrogen combines with the 1 oxygen. Another example for a compound from hydrogen and oxygen is hydrogen peroxide. And here they are in the ratio 2:2, or we can simply say 1:1. I will discuss another example that will be easy. Simple example. First first we'll discuss carbon and oxygen. Carbon combines to form carbon dioxide and carbon combines to form carbon monoxide. Here, first compound carbon combines with 1:2 ratio, another one 1:1 ratio. Here, the mass of one of the element is fixed in two compounds. If it is fixed, then the mass of other two will be in a simple ratio. That means mass of oxygen and O2 and O in a simple ratio. We know that here 32 gram of oxygen combines with the 16 gram. That means they are in a ratio 2:1. That is called law of multiple proportion. When two elements combine to form more than one compound, then different mass of one of the element combines with fixed mass of the other, carries a simple whole number ratio. We can write so many examples using nitrogen and oxygen, NO2, nitrogen trioxide, or we can write with the sulfur and oxygen, sulfur dioxide, then sulfur trioxide. All this we can prove that if one of the elements mass is constant, the other mass will be in a simple whole number ratio. That is called the law of multiple proportion. When two elements combines to form more than one compound, then different mass of one of the element combines with the fixed mass of the other carries a simple whole number ratio. Same way we can explain the other example, that is hydrogen, water and hydrogen peroxide. First if we discuss that, you will get a confusion, that is I am saying now. Here mass of hydrogen is constant, O2, hydrogen 2. Then the mass of the other will be in a simple ratio. What is the ratio? They are in a ratio 1:2. So we can prove all the examples of two elements if they form more than one compound. If one of their mass is fixed in all that compound, then the other elements masses will be in a simple whole number ratio. That is, when two elements combines to form more than one compound and different mass of the one of the element will combine with fixed mass of the other, carries a simple whole number ratio. Then we will go to the third law. Fourth law, Gay-Lussac's law. Gay-Lussac's law of combining volumes. Combining volumes. It's a simple law. This law is applied only in the case of gaseous reactants and products. According to Gay-Lussac, when gases combines to form gaseous products, they will do so in a simple whole number ratio. For example, hydrogen gas combined with chlorine gas, all these are gases, forms hydrogen chloride. It's also a gas, hydrogen chloride gas. When gases combine to form gaseous product, they will do that. They will combine in a simple whole number ratio. What is the ratio? 1 volume of hydrogen combined with 1 volume of chlorine to form 2 volume of HCl. So they are in a ratio 1:2. Simple, and it is a whole number. That is called Gay-Lussac's law of combining volumes. According to Gay-Lussac, when gases, it is only applied in the case of gaseous reactants and products. When gases combines to form gaseous reactants and products, they will combine in a simple whole number ratio. That is called Gay-Lussac's law of combining. Then next and the very important law, what is that? That is called Avogadro's law. According to Avogadro. Avogadro initially that suggested the law for only gaseous elements or compounds. Later it is applied to all the substance that may be in different physical state. According to Avogadro, if temperature and pressure is constant, that they are the two properties of matter, temperature and pressure. We will discuss later. Temperature and pressure. If temperature and pressure constant, equal volume of all gases. If we take different cylinders with the equal volume, all these contain same number of particles. From the first one we will take chlorine, hydrogen, then oxygen. They are in the same volume. Then their number of particles, that is called N, number of moles, number of particles, there may be molecules or atoms, they will be same. So according to Avogadro law, under similar conditions of temperature and pressure, equal volume of all gases contain equal number of particles. That particles may be atoms or molecules. Equal volume of all gases contains equal number of particles under similar conditions of temperature and pressure. Then he fixed some temperature, pressure, volume, etc. Then and take a fixed amount, that is 22.414 liter of any gases contains a fixed number of particles, and it is called Na or N0, that is Avogadro's constant, and that particles number will be 6.02213 into 10 raised to 23, and it is called, he named it as mole, 1 mole.